Good morning, astronomy. We're going to talk, hopefully not for very long, kind of finish out the notes yesterday from the chapter that you were to have read. We're going to talk some about things hitting the Earth. But before we get to that, I wanted to kind of take a look at the assignment that I left for you, which you can find in the stream, or you can also find it in Classroom. It's no, that's not it. So where's my assignment? Did I not assign it? I haven't actually assigned the thing yet. Wait, no, I'm looking at physics. That explains why I can't see it. Okay, here it is. It's called the privileged planet. So for this, what you'll do is you'll open up a Google Doc that I've got on there, and you'll go to the link that's on there and also back on the site. And there's a documentary there called The Privileged Planet, which talks about, factors necessary for life to exist on Earth. You'll watch the first 30 minutes of it. If you want to watch the rest of it, please be my guest. I think it's a really good film, otherwise I wouldn't have recommended it. And as you go through there, on the doc, anytime they bring up, I think the first one they actually talk about is liquid water, but they will then go through a laundry list of other factors necessary for life to exist there. So you'll add the factor to the column on the left, and then just briefly in a sentence or two, write about why that factor is important for life to be able to exist on our planet. I think I've got on there minimum of 10. If you want to add more lines and continue on from there, that's fine. But at the very least, get down 10 and why each one's important. And then you can turn that in. You've got till tomorrow night at midnight to get this done, so no rush. But I just wanted to make sure that you knew that that was there. Let me get back to the, where I put it? Let me get back to the slideshow from yesterday. Astronomy, solar system, Earth is a planet, there it is. And I believe we had got through the first several sections. We were about to get to, okay, we've done Earth's atmosphere. Yeah, only 2 slides to talk about today. We're going to be looking just real briefly and talking about cosmic influences, about other things outside of the planet that have had and continue to have an influence in what's going on the surface here and on all the living things that are here. So a question that pops up, when you look at rocky planets, when you look at moons, you notice that there's a lot of craters. And the question that comes to mind is, okay, well, Earth is a rocky planet. Why aren't we just absolutely completely covered with craters too? And main reason for that is that unlike pretty much all the other rocky planets, we have active processes going on the surface. We've got weathering, we've got erosion. And so most craters that have been on the planet to a large degree have already been weathered and eroded away. Some of them you can still see either from space or by taking like seismological measurements or shooting radar down in the ground and having it bounce back and staying like under rock formations. But a lot of them have been covered over by desert, by ocean, and then just through regular destruction and cycling of the planet's crust through plate tectonics. There are a few that are still around. This one right here that you see in the little tiny picture is from that particular chapter in the textbook. I think it's like in Algeria, I could just be making that up, but I want to say that's what I remember reading. But there are a few, and we'll look at one on the next slide, or a couple on the next slide that are still there. But things continue to crash into our planet all the time. One of the most recent notable ones happened back in 2013 in Russia. And this really, it was super cool when it happened because a lot of people caught it on video. this massive fireball is screaming through the sky, and it kind of hits, and there's this big flash and boom, and everything just kind of shakes because a little 20-meter meteor, that's hard to say, uh, hit about 21 kilometers up in the atmosphere. It didn't actually get all the way to the ground, but it exploded and showered little pieces of itself all over the place. It was the equivalent of about a half megaton blast, as far as, like, if you're looking at, so about a 500,000 tons of TNT would be the equivalent there. They measure things like nuclear bombs in megatons. So anywhere in the area there, it blew windows out. A lot of people had to be hospitalized. It ruptured a lot of people's eardrums. And there were numerous pieces of this thing all over the place afterward that had fallen to Earth. Another big notable one that happened back before that, back in 1908, so just 112 years ago or so, still in Russia, what was estimated to be a 10,000-ton meteor was crashing toward the Earth, and I guess it built up enough heat as it was falling through our atmosphere that it exploded about 8 kilometers up, or just close to 3-4 miles up in the air, and it let out a 5 megaton blast. So it was about 5 times more powerful than the one that hit just a few years ago. Which, the one that hit just a few years ago, you can totally go look up on YouTube. In fact, I'll see if I can find some video and I'll add it to the playlist I've got on YouTube for this section. But it completely leveled a forest. I've got a picture on the next page of some of the trees in that forest from that blast, like years after it happened, and they're still just all completely laid out. There was one guy who was 80 kilometers away. He was 40, 50 miles away from this whole thing, and it hit with so much force it blew him out of his chair across the room. And that was just one of the things that was documented from this thing. It's fortunate when things like this, a lot of times when asteroids or meteors crash into the Earth, even the ones that make it all the way to the ground, for one, they don't tend to be that huge. The one that hit a few years ago, it's only 20 meters, so that's, about the height of a, 20 meters, that's about 20 yards. That's still pretty sizable, okay? More than halfway the length of a football field. But still, compared to some of the rocks floating around up in space, it was still fairly tiny. Sometimes they hit in places where there's not a lot of people, okay? Like in Siberia, it's pretty remote. There's not a lot of high population there. Or, most of the surface of our planet is covered with water. So a lot of times when things crash through the atmosphere, if anything survives all the way down, it'll just hit the ocean, send up some splash, send up some steam. But for the most part, asteroids and meteors that make their way all the way through and actually hit don't tend to do that much damage. As a notable exception to that, about 50,000 years ago, a great big one. Now they're saying that this is just 40 meters, but it was iron, and instead of exploding in the atmosphere, it actually hit the surface. It caused a crater that is now referred to as Meteor Crater. It's still in Arizona, and it's more than a mile across. And from the rim down to the bottom, I didn't catch how deep it was, but you'll see in the picture that I show you in just a minute that it was pretty big. It left a pretty big mark on things. Now, but even that, that's going to kick up some dust. It's going to cause, some shock waves in the area, but it's going to be fairly localized. Sometimes, and we know of at least once that this has happened in Earth's past, some piece of space, well, by doubling the size, you make it more than double the damage. Yeah, I'm not exactly sure, if there's like I'm sure there's a mathematical relationship to that. I'm sure, the physics of it, if you look at the speed and the momentum of these things and like how much force they're imparting when they hit, also like what the density of the space rock is, if it's iron or if it tends to be rocky or something like that. I'm sure that makes a difference. But we know of at least one time in Earth's past when something big hits. And 65 million years ago, give or take, a estimated 1 trillion ton space rock got through our atmosphere, and it smacked into the Yucatan Peninsula down in Mexico. And the blast, they're able to tell by the distribution from this and by the size of the crater it left, they estimate it to be about the size of 5 billion times bigger than the bomb that we dropped on Hiroshima back in World War II. It left a 200-kilometer crater. Okay, that's not quite 100 miles wide. And it hit so deep it actually pierced through the Earth's crust and hit the mantle. What this did is this kicked up so much dust that it clouded over the atmosphere for decades. And so since it clouded over the atmosphere for decades, from what we've been able to tell, because bits of this stuff and ash from this stuff has been found all over the planet at about the same depth in the rock layers. And so they know that the stuff was worldwide, the effects of this. It dimmed the sun so much, it killed off a tremendous amount of plant life. It lowered global temperatures. And basically, after that, we didn't have any more dinosaurs. Okay, it was what's called an extinction level event. And it caused mass extinction of a lot of living things. It really is crazy. Kind of the good side of it, if it hadn't been for the dinosaurs becoming extinct, then we would not have seen the rise of the mammals. Yeah, gone but not forgotten. Peace out, dinos. But had it not been for that, the dinosaurs could have still been, or their descendants could have still been ruling the planet, and we wouldn't have had the rise of the mammals that eventually, led to us. So, bad news for them, good news for us, I guess. Now, a couple questions I got from your reading the other day is, could something like that happen again? Absolutely no reason why it couldn't happen again. NASA and other international astronomers have been tracking. They've got a project together where they track large objects that are in the solar system, and especially the ones that will come within a certain distance of us. Now, 99.999% of those never get anywhere near us. But there are a few that make some pretty close calls, and have made a few pretty close calls, and probably will continue to. And so there's absolutely no reason that something like that couldn't happen again. And I really don't know how much warning we'd have if it did. Now, another question I got is, well, what could we do about it? Not a whole lot, to be totally honest with you. Hollywood has presented us with, nuke it. Hollywood's presented us with a few different, possibilities for that. One of them is, hey, build a deep enough underground bunker, or several of those all over the planet, to where hopefully we can survive, something that would decimate the surface of the Earth. Another one is, hey, let's fly some, some spaceships up there, like in Armageddon, and let's try and put some nuclear bombs on the thing and blast it into pieces. If Bruce Willis is still alive when this happens, there might be a little bit of chance of hope that this could happen. But in reality, there's not an awful lot we could do about it. The good news is, if something like that hit the planet, there's a really good chance that we wouldn't be around long enough to really say, oh, dang, it got us. But it's one of those things I personally don't worry about, because I know there's not much I can do about it, and so why worry? But just so long as yes, it could happen. Now check this next slide out here. So the picture on the left is from that blast in Siberia, and I want to say that these are trees that were knocked down and flattened, and this picture was taken 20 years after the one hit back in 1908. And you can still see how, there's a few new trees that have grown up, but look at all these that are just laid out from that thing. The picture in the middle right there, that's Meteor Crater in Arizona. It's a very popular tourist attraction. I think it's not too terribly far from the Grand Canyon, so if you ever get over there, I've never been over to see it, but I'd love to. Have you? That's cool. And then in the picture right here, I've got just a map. Now, the crater in Yucatan Peninsula isn't as readily apparent anymore to the naked eye because, it's been however many millions of years ago that happened, so a lot of erosion and stuff has kind of taken it over. But they have still been able to find the thing, partially by looking at it from space, partially just by shooting radar and other stuff down into it. Look at the size of this crater. Okay, there's the Yucatan Peninsula down there on Mexico's toes. It was big. So I guess that really takes us to the end of now. The only other thing, and I'll mention this again because Mason kind of had a question about that. There are a lot of theories as to how life got started on the planet. Now, this is not so much talking about, theories of evolution and natural selection, which is really more of a way of explaining all the variety of life on the planet and, how living things change and adapt over generations and over time. But even there, you've got to have some kind of life to start with. And so, Darwin never could satisfactorily answer, where did life come from to begin with. So there's been a number of different theories about this. One theory is, aliens. One theory is something called chemical evolution, where the idea is that, we had, enough random chemical ingredients going on in the atmosphere and in the oceans, and energy from lightning and other stuff caused those molecules to form increasingly complex molecules. There's a lot of problems with that. Main one being that, left to their own devices, matter doesn't become increasingly complex. It tends to do just the opposite because of entropy, because of disorder. Things become less and less complex. And so sometimes scientists have turned to the idea that, well, life came from some other place. Either it was deliberately put here by aliens, or maybe meteors or something carrying primitive organic matter from other places landed on the Earth in such a way to where they weren't burned out, and so that's how life got here. In my opinion, I'm going to sneeze. Maybe not. In my opinion, I think that's just getting to fourth down and having to punt. That doesn't really answer the question. It might help answer the question and say, okay, well, let's say that living cells came from space. How did they get there in the first place, wherever there was? At some point, you've got, the more and more you look back, you've got to be able to point your finger and say, aha, so that's how it all got started. And thus far, although there's been a lot of really intriguing research, a lot of really intriguing experiments, ways to simulate early Earth and things like that, going back to like the 1950s, 1960s. Yes, thank you, Jeff Goldblum. Life finds a way. It still doesn't definitively answer the question, where did life come from? All we know is that we got it here. As far as we know, we haven't found it anywhere else yet, although a lot of people are still, expecting that they will. Which brings me to the video I'm going to have you guys watch, because it's really cool. Because it talks about, okay, well, mathematically, what are the odds that you would have a planet like Earth, that everything would be just right in order for life to appear and develop? And what's the odds of that happening more than one place, given the size of the universe and given the amount of time that we estimate the universe has been around? So they come to some really interesting conclusions in that video. So I'm really interested to hear what you guys think about it after you have a chance to watch it. Having said that, I think I am going, it's been not quite 20 minutes. I'm going to honor my promise and go ahead and shut up and let you get on that. So I'm going to stop the recording. If you have any questions, feel free to stick. Don't bug out just yet. I do want to get a picture of our guest list here for attendance, but you guys go watch the thing, go find out, what actually makes life possible, and I'll talk to you about it.